Howdy, I'm Charles Liu, application engineer at Markforged. Take a look at this lever. It's an onyx part, printed solid because you need it to be really strong. What if I told you you could cut print time in half, double the stiffness, and still maintain strength and cost? With the power of software and a little bit of continuous fiber, that's all possible. Let's dive in and I'll show you how. As engineers, we are always making trade-offs between quality, time, and cost. With 3D printed parts in particular, finding the right balance of settings to meet functional requirements can be difficult. We need the new part to be strong, quick to print, and cost-effective. And in the past, we'd have to print and test multiple iterations to dial in the settings. It took a lot of time and a lot of materials just to get to a design that worked. Not anymore. Simulation from Markforged allows you to test your part virtually to see if it will be strong enough. You can then optimize the print parameters, including the placement of continuous carbon fiber reinforcement, all before you hit print for the first time. So let's use this lever as an example. You need it to hold a 100 Newton load with a factor of safety of at least 2. And it can't deflect more than 1 millimeter and needs to be as light as possible. How would you achieve that? Let's look at 3 different variants of the lever. The first was printed with default slicer settings. The second with a solid infill. The third part is optimized using simulation. We can see in Eiger that the first part took 3 hours and 32 minutes to print. It's not strong or stiff enough for us to use. The second print with solid infill took 6 hours and 19 minutes to print. It meets the factor of safety of 2, but has a maximum deflection of 1.8 millimeters. The third print, optimized using simulation, took 3 hours and 41 minutes to print. It meets the factor of safety of 2, cutting print time almost in half with the same required strength. With simulation, it took only a few minutes to simulate and optimize this part. Meanwhile, it takes 14 hours of printing just to arrive at the same conclusion. No more guessing how much or where to place fiber, or spending countless hours on print break cycles. Print the right part the first time. For more information on how simulation can save you time, money, and materials, click the link below. And thanks for watching.